So in this next part, we're going to talk about finding slope from 2 points. So we know that f of x is a linear function, meaning it has a constant rate of change. Another way of thinking about that is the rate of change between any 2 points, or the slope between any 2 points on this function, is going to be equal, regardless of what the points are. And that kind of plays into the idea that 2 points on a line defines the entire line. And that's because slope is constant, rate of change is constant for a linear function. So there's 2 things I can do to find the slope of a line. So if I have 2, 3, and I have 0, 4, so I could label this as x1, y1, 2, y2, and I could use the fact that slope equals y2 minus y1 over x2 minus x1. So that's going to give me 4 minus 3 over 0 minus 2, 1 over negative 2, or negative 1/2. And this tells me, since negative 1/2 is less than 0, that this is decreasing. So we'd say f is a decreasing function. To represent this graphically, I can plot my points. So I have 2, 3. And then I also have 0, 4. And so I know that my linear function is just going to be the line through these 2 points. In order to do the slope, I just need to use rise over run. So my run, I'm going down 1. So it's important to be aware that how your direction moves affects what your slope is, especially with the sign. So I'm going down 1 and then I'm going over 3. So here I see that my slope m equals rise over run. That's the same thing as y2 minus y1 over x2 minus x1. The rise was negative 1. Sorry, this should be a 2, right? Over positive 2, which is the same thing as negative 1/2. And we get the same result, right? I could look at the slope and say it's less than 0, so f is decreasing, but I could also just visually inspect here, because they're not asking, well, they are asking to find the slope, fine, we did that, but they're also asking, is it increasing or decreasing? So just by visual inspection, I can see it's going down and to the right, so it is a decreasing function, right? So we come to the same conclusion here. So now if we want to write an equation for a linear function, we could do 2 things. We could use y equals mx plus b, or we can use point slope form. For this section, I'm just going to use y equals mx plus b, because when it comes to a function and word problems, it's easier to describe it in terms of an initial value, your starting point, which again is your y-intercept, and then tacking on to that, how does this function change over time, which is your slope. So we can see right away that my y-intercept is 0, 2. So that means that b equals 2. And then I also have to inspect my slope. So I can use any 2 points to do that. I'm going to use ones that go nicely through the crosshairs on the grid. So I'm going to get +1, +3, right? So right is plus, left is negative in terms of run. Up is positive, down is negative in terms of rise. So here I'm going to get rise over run, which is our slope, equals +3 over +1, which is just 3. So now I'm ready to state my equation for this linear function. So I get f of x, because we're talking about functions now, we're not going to use y. We get f of x equals 3x. I see I've made a mistake. The scaling here is by 2. Okay, no worries. So I went over plus 2, and then I went up to 4, 6 plus 6. Because the x and y axes are scaled equally, I still end up with my slope equal to 3. All right, good save. So I've got f of x equals 3x plus 2, and that is my function shown in the graph. All right, so now let's work on writing an equation given a verbal description. So Ben starts a company in which he incurs a fixed cost of $12.50 per month. Fixed cost. So that means that every month, regardless of what happens, it's going to cost him at least $1,250 to run this business. That's in his overhead. And then his production costs are $37.50 per item. So our total cost is going to equal $12.50 plus $37.50 per item, right? And this is kind of just our rough draft, right? This is our cost. So let's let X equal the number of items. That Ben produces in 1 month, because we're creating a function that determines his monthly cost. So then C of X, so capital C for cost, depends on how many items he produces. So C of X, where X is our independent variable. For every item that he produces, it costs 37.5. So that's going to be our rate of change. So 37.5 times X plus he's got $12.50 in overhead. Right? So your initial value, or your flat cost, constant cost, plus the cost it takes to produce each item. All right, so now we're going to write in example 7, we're going to take a linear function and write an equation for it. So typically we've seen, okay, let's say I have the point, I'm just making this up. Let's say I had the point 0, 1 and the point -2, 5, and then I wanted to write an equation. Right, so the first thing I would do is I would compute the slope. Then I would determine B. And then I would produce right? We're going to do the same thing here, but what are the 2 points that they're given us? So I have f of 3 equals -2. This is the same as the point 3, -2. If I have the equation f of 8 equals 1, that is the same thing as the point 8, 1. And so now I'm back where I was earlier in the term, where I'm given 2 points and I need to write the equation of a line. So the first step is slope. So I'm going to do y2 minus y1 over x2 minus x1. So if this is x1, and this is x2, this is y1, this is y2. So I'm going to have 1 minus -2. Then I'm going to have 8 minus 3. So this gives me 1 plus 2 over 8 minus 3, which is 3 over 5. So this is my slope M. So in order to determine B, I know that y equals 3/5 x plus b, but I don't know what b is. So I'm going to use any point, either point, to plug in here, and then I'll be able to produce b. So let's use the point 3, -2. You could have used 8, 1 as well, but dealer's choice. So that gives me -2 equals 3 over 5 times x, which is 3, plus b. So I get -2 equals 9 over 5 plus b. I'm going to subtract 9/5 from each side so I can isolate b. So I get -2 minus 9/5 equals b. And now I need to convert -2 into something over 5. So this will be -10 over 5 minus 9 over 5 equals b. So -19 over 5 equals b. And then I just put that all together. I have y equals 3/5 x minus 19 over 5. But again, this is talking about linear functions. So let's just go ahead and write that as f of x equals 3/5 x minus 19 over 5. All right, so next we want to match a linear function to the graph. So really what's going to come into play here is we've got to look at m and b. So let's make a little table here. So we've got a, b, c, and d, right? So these are our functions. We've got a slope and we've got our initial value. So for a, our slope is 2 and our initial value is 3. For b, our slope is also 2, but the initial value is -3. For c, I've got -2 as my slope and initial value 3. And then for d, I've got 1/2 and 3. So there's only one equation here that has a negative slope. So that's got to match up with the line that's going down and to the right. So let's match it up with their line. So here we have the only one with the negative slope was line 4. The other 3 all have a positive slope, but one of them is shallower than the other. So the higher the number, the steeper the slope. So D has a shallow slope relative to A and B, but it's still positive. So I'm looking at the 3 positive lines, which are this one, and this one, right? Positive slope. But we can see that line number 2 has a much shallower slope. So that tells me that line D, or function D, goes with equation 2. And now I just have to differentiate. So we've already ticked off 2 and 4. I just have to differentiate between 1 and 3. Well, they both have the same slope. So what's going to set them apart is their y-intercept. So A has a positive intercept at 3. So that means that it has to be line 1. And B has a y-intercept at -3, right? Which is right here. So that means that this has to be line 3. All right, so the next example is going to be determining whether lines are parallel and perpendicular. So we've already done this previously. But just remember that perpendicular, you have your slopes m and -1 over m. And for parallel lines, you have the same slope, m and m. So if you need a review on that, you can go see module 1. And then this is also another quick little review. So horizontal and vertical lines that are horizontal have a slope 0. And they also have the equation y equals a for whatever its y-intercept is. And then, oh, excuse me, I used y equals b. And for vertical lines, so let's draw a horizontal line really quick. So this is some height b, could be positive or negative. So here you just have f of x equals b, right? Slope is 0. For vertical lines, we saw this in exam 1 and in module 1. I call this a. You just have the equation x equals a, and your slope is undefined because it's division by 0. There is no run. So this hopefully was mostly review. I just wanted to kind of contextualize it, I guess, moving from y equals mx plus b into f of x equals mx plus b, and then kind of going through all of these steps.